Okay, hello everybody. Thanks for joining today. My name is Jason Gumpert. I'm from msdynamicsworld.com, and we're here for a session all about building an emergency response system in Dynamics CRM with Azure IoT and Bot Framework. Our speaker today is Stefano Tempesta. He is the VP of Engineering at EF Education First, and it's really a pleasure to welcome Stefano today for a session that looks at some of the most interesting, I think, and most compelling new technology from Microsoft and how it's being used in a really valuable scenario here. So please know that you can ask questions today. Look for the question block to the right side of the main presentation area. Enter those anytime. I know Stefano will be making time for questions. And without further delay, let me hand things over to you, Stefano, to get things started.
Excellent. Thanks, Jason, and hi, everybody. So, as I kindly introduced, my name is Stefano Tempesta. I work for EF Education First. We are using Dynamics CRM for a number of applications, mainly for sales automation, obviously. The experience today is an experience about using a bit of the latest technology in Azure, the IoT suite, the cognitive services, the bot framework, and we have a roadmap also introducing additional services like machine learning and so on. The idea here is build a dashboard for responding to emergency events whenever they occur in any of our schools in the territory. EF has over 150 schools in 50 locations around the world. We have a regular intake of students from age 8 to adult, and safety is paramount, obviously. And you have probably heard about even recent events like in Berlin or last summer in Nice, Munich, over here in Europe. I'm based in Switzerland, and this is a concern of ours. We want to provide the best safety response to our students. Obviously, it's not only about this terroristic event. It may be a flood, it may be a fire, it may be a riot, anything that will create a concern around safety of our students and staff in school. Hence, we designed a solution that basically starts with the definition of the event, and then using a combination of dynamic CRM, where all our students are profiled, and the courses and the schools, and obviously the association of a student to a school, so we know at any point in time which student is in which school. We created a dashboard. This dashboard, I will show you in a moment, is hosted on a SharePoint portal. So Dynamic CRM is our backend, providing all the data that we need to generate a roster or a dashboard for managing communication with the students. The integration between Dynamic CRM and dashboard is processed by a workflow defined in Logic App. Logic App is another service by Azure. I will show you the workflow as it is designed, and it's very simple in some way, but it just has some logic for moving student, or actually not moving, but for transferring data from the student backend in CRM to the dashboard in SharePoint. Once in the dashboard, this information then is used for reaching out on the students. And we do a couple of activities for assessing the status, the safety status of our students. First, we look into their location, and we have a few ways of determining their location, which I will speak in a moment. And then we initiate automatic communication via bot, sending an SMS or a message in Facebook Messenger or over Skype for understanding if they are in safe conditions or not. Now, why we are doing all this automation? We do it because on a regular day we have even up to 3,000 students in a school, and reaching out, calling them is not obviously time effective. So we want to have an initial assessment which is simply an assumption of their safety based on location and status using the Azure technology that I mentioned at the beginning, the IoT Hub for tracking their location using GPS devices, and the bot framework and the cognitive services by Azure, again for initiating conversation with the student in an automatic way. Obviously, this is an initial filter. Then those that don't reply, those for whom we don't have an exact location, we reach out with a phone call. All of them, all of the students are in any case, lastly, connected with an operator in the school for assessing and confirming their safety status. So that's the agenda for today. Let's try to go through all these pieces one by one. I will switch between the slides and a real demo on the system. So forgive me for a moment if I just exit my PowerPoint and jump into a virtual machine where I have my demo development environment on Dynamics CRM, obviously. So here is our sales dashboard. Hopefully you can see, maybe I'll try to zoom in a bit, try to give a bit more visibility. But pretty much is ordinary dashboard where we have a list of all the active programs in a school, English level 1, level 2, and so on. We have a few schools that have been classified in the system, Cambridge in the UK or Sydney Language Center in Australia, and we have a number of active students that are in a different location, obviously. And for each student, let me pick any, Maxim. We have a student information page where, besides the detail and obviously how to reach them, we know in which school they are currently taking a course, what is their accommodation, whether they are in a residence or in a host family, and which program they are enrolled to. Now, the accommodation is important because the way we reach out on students is a workflow of escalation where the student is the first point of contact. Obviously, we want to assess their status, but after that, we also, if we don't make contact with the student, we check with their host. Are they in a family or are in the residence provided by the school? Another point of escalation is also with their parents or the emergency contacts that we register on the intake day. And again, that will basically generate a kind of audit of all the elements, of all the moments of contact that we establish with the students. It's very important that we keep a very detailed audit trail of all these communication activities, because if in the future we have some legal requirement for providing evidence of all the efforts that EF has done for contacting students, then we have a log of all these activities, which are via email, via SMS, phone calls, and so on. So this is the initial backend in Dynamics CRM. I will show you now how the dashboard looks like in SharePoint before we actually jump into the workflow and see how the two systems talk to each other using Azure Logic Apps. And then obviously we'll carry on with the other area of the demonstration itself. So spare with me a second, I need to switch to another virtual machines. My laptop is not powerful enough to run the two virtual machines at the same time. So I'm switching this off and I'll taking the other one on in a second. And then, here we go, this one is done. I'm moving to the dashboard. In the meanwhile, let me just have a okay, 1 second. I'm probably running out of memory here. Too many applications open. And let me try this again. Okay. Okay, that's interesting. There we go, getting better. Sorry about that. This restoring of the virtual machine in action now, so we'll get there in a moment. So in the meanwhile, that the virtual machine restores, so that we can show you the dashboard in action. The way the communication happens, as said, is between Dynamics and SharePoint is using the Azure Logic Apps. The Logic Apps don't have a logic per se, is a workflow. So I don't want to build a business logic in the workflow. What I want to do is build an integration logic that basically identifies condition like the student is in the school, and that is a relationship maintained into the CRM. And that is a condition for creating my dashboard, my roster, where I can have a list of students in the school that has been affected by an emergency event. So in this case, now we are in SharePoint. My workflow is executed. We'll spend a few more time on the workflow just in a moment. We have a road evacuation emergency event in Cambridge. And these are the students that are currently in the school. And for all of them, we have their current safety status as assessed by the initial location and the communication by the bot. So, for example, if I look at, I expand this a bit so that it's clear, and give a bit of zoom here so we have better visibility. Here we go. This can go. So for example, if we look at Christine is safe because the initial conversation made by the bot sent a message, and for some reason we decided to call our bot Bob. Okay, so Bob is our bot and is sending a message to Christine asking if she's okay or not. She replied yes, so the initial assessment is safe. So the bot is able to understand the reply, and I'll come back on the detail of the implementation of the bot in a moment. So Christina is safe. Caroline Mueller, she's unknown. She's unknown because she didn't reply. So we need to process this with a manual intervention. So we don't know her status. Bob has sent the email, the SMS. So this is our bot again, but we don't know if she's safe or not because she hasn't replied. So we need to escalate this to the next intervention. Maxime instead looks like is in danger. What happened? So our bot again sent a message, and the reply was no. Then it's been asked, do you know where are you now? This is the second message that the bot has sent. And we didn't hear from him, so this is again by the bot. And then an operator, in this case me, couldn't reach him over a phone call. Hence, his status is marked in danger. Now let's have also a look into Thomas. He's marked as safe, but if you look at this, he didn't reply to the message initiated by the bot. So why is it safe? Instead, Caroline was marked as unknown. That's because of the location. So if we have a look at Thomas' location, the last location is being recorded. Oops. Okay, here we go. The last location Thomas has been recorded is a location where the blue pin is Thomas, the red pin is where the event occurred. There is a rule that we have coded into the IoT Hub in Azure that says basically if the location is more than 100 meters from the event, the location of the student is more than 100 meters from the event, then we assess the status as safe. So there are a number of rules that have been implemented and contribute to determine the initial safety status of the student. Obviously, it also depends on where that has been reached. So if I go back here and we say this has been assessed 5 p.m. and the event occurred a few minutes ago, then it means that the location is accurate enough. But if the location has been recorded more than an hour, then we make no assumption on it. So there are a bit of rules that we apply and will help to determine the initial status. So let me get back now to the slide, which I had to close because my laptop was running out of memory, so I'll open it here in a moment. Here we go, and let me just jump very quickly into the data model, which actually is even better to see directly in Visual Studio. So the data model here, until Visual Studio opens, is a bit like we have seen it, where we have a number of elements, entities that are defined in dynamic CRMs purely from a sales and asset perspective, where we have our host family and our residents. They are a type of accommodation. We have our programs that we deliver, which are our courses, and then we have the definition of school and students. When an emergency event instead is defined, the emergency event is defined in the emergency dashboard, and typically only school directors have the privileges to create a new emergency event, then a roster is defined. A roster, in our terminology, is basically a connection of an event with a school and a list of students. So all the students in that school affected by that emergency event generate a roster. For all the students, we have tracking of all their communication, so and location. So the last location detected, the when was detected, the current safety status, and who has marked the student safe or unsafe, and then a list, a log of all the communication that have occurred between the bot or the school operator and the student itself. And we obviously track the channel, is an SMS, is an email, is a messenger, is a voice call, and so on. So let me now jump into the integration workflow built on the Logic Apps and show how that works. So Logic Apps is a relatively new service of Azure. It allows to do a bit of integration among different systems. It's not specific to Dynamics CRM or to SharePoint. There are two of the many connectors available, and you can create a bit of conditions. If yes or not, apply this rule and send an email, send an SMS, and so on. So again, let me jump off PowerPoint and go into my Azure portal, which now has to reopen again. And if you have an Azure subscription, you can easily create a Logic Apps workflow. All you have to do is create a new service, search for Logic App, and it comes up first of the list, and Logic Apps allow developers to design workflows that articulate intent via trigger and a series of steps, etc. Now, we're not going to create a new workflow right now because I already have my integration workflow designed. So what I'm going to do, I open the existing workflow. I put it on the screen here. And that's the sequence of steps. There is a trigger on SharePoint. This is my demo instance where I look into an emergency event. When this is a custom list in SharePoint, school directors can create an emergency event through a form in SharePoint. The workflow checks every minute if there is a new list item, and when an item has been created, that's the trigger for executing this workflow. So the next steps is going to Dynamics. So this little icon here is a Dynamics connection. And it goes into a specific organization name. Again, that obviously will be your organization. Into a specific entity. In the data model, that's my contact, where all my students are. And then execute a sequence of steps for each student. So for each student, it will create the student in the roster and then invoke an API in the Azure IoT to send an awake message to the GPS device. I'll speak about the GPS device in a moment. And once this is done, we send the location to the roster. So the device, which is registered into the IoT Hub, will send as coordinates, geographic coordinates of latitude and longitude, and the date and time of detection of the location of the student to the workflow as a response. Is a call, is an API call, is a web API, so it's a RESTful call with a JSON message, and then this is sent to the roster in SharePoint. I wait a bit. There is a 10 seconds delay just because we are using an SMS gateway. We need to give a bit of time to breathe between actions. And then this is my Bob. This is my bot called Bob, where we send a JSON message. Again, is a REST API call by post, where we send the student ID, which is coming from the roster in SharePoint, and we send an ID of the message that we want to send. The ID of the message is simply "Are you okay?" And I will show you in a moment in Visual Studio how that is defined. As you can see, it's all in JSON. It's a RESTful API. This will send the message to the student via the bot framework. If I were to continue this workflow, and I'm not going to make a specific demo Logic Apps designer at the moment, but you will basically add an action or a condition, or even more, you can add a for each or a loop. If you look into the actions, there are incredible number of actions that you can do, which is, again, is a delay, or call an HTTP API, or validate an XML message. If you type Dynamics, for example, then you have a list of all the actions that you can do against a Dynamics 365 instance in this case. You can create a new record, you can create you can list existing records, or you can trigger action when something happened, like a record is created. So this is important to see that workflows now are going outside of the system. So it's not a workflow initiated inside Dynamics, or the other way around. It's not a workflow initiated in SharePoint. Both systems, SharePoint and Dynamics, have workflow capability. Here instead we are using an external application in Azure. It's a Microsoft application, but still external to Dynamics, external to SharePoint, to communicate between the two systems. Why is that? Because first of all, we create a workflow that has no dependency on each system. If we want to modify, we can do it in any without knowing Dynamics or without knowing SharePoint. Is purely in Azure portal, and also because we can integrate with a very high number of external applications just by using any of the pre-configured existing connectors. So there are connectors for Azure Machine Learning, but also to Box, to Dropbox, to Facebook. So if we want to send a message, we're not, in this case, we're not going to send message on social media, obviously, but if we were to integrate a dynamic CRM and SharePoint and Facebook and maybe create a file in Box or Dropbox and so on, then Logic Apps is the tool that will give you the connectors to all the system. It is a no-code application. There is no coding. You just have to understand a bit how to configure a JSON message and send information among systems. All right, so that was our integration workflow in a nutshell. Let me speak to you about the way we do location tracking. So we said we are using a number of GPS devices. These come in the form of key rings that have a small GPS unit, and they are assigned to each student on their intake day. But we also have mobile apps, and we have done something also for the Microsoft Band. It was more for the fun of it, if you want. And we're looking into the iWatch as well. Any device, any mobile device that people take with them and send a GPS message. This message is regularly, as in every hour, so not extremely frequently, but for a bit of privacy concern and obviously for not overloading the application, we send a message about location every hour. Each device is registered into the Azure IoT Hub, and that's important because the IoT Hub is your expose basically a number of APIs. So the communication is through APIs. We don't want this communication to be tampered with. And the way we enforce security is by registration of a device. So only registered device can communicate with the API exposed by the IoT Hub. Besides that, these devices are typically in low power usage. So they go in standby if they're in between signals. And in order to send a regular signal, the IoT Hub has to send an awake message. So the device is actually sleeping in standby mode, so to reduce power consumption. The IoT Hub has a rule that every hour has to send an awake message to the device. The device then wakes up, captures the current location, and send latitude, longitude, and a timestamp. This is captured in the IoT Hub using DocumentDB on the back end, and just for caching purposes. And in the workflow, as we have seen before, this information about the location is sent to the roster and then stored into a SharePoint list. As this is done, there are a number of rules and actions that are applied in in assessing the initial safety status of the student. So let me show you something in the dashboard again. So if we go back here to my SharePoint, let me zoom in a bit so that it's a bit easier also to see from a distance. We said that Thomas we consider safe despite not being able to communicate with him because the location is distant. So this is here we go. This is a dashboard of where all my students currently are in their last detected location. Thomas is far away, Christine is far away, Alexander is far away, Gabor is far away, and they are marked in green because obviously their safety status has been assessed as safe. But there are some rules that we can change, and if I scroll down a bit, we can see all the students in here. The rule is if the proximity, so if the student is closer than 100 meters to the event, then the action to send is send an alert, a danger alert. So for example, in this case, the Gabo was really close to the event, although it's still more than 100 meters using the Bing API for geolocation. So if I change that, Gabor is here, so if I go and change the information about Gabor and I say Gabor is now at 400 of latitude, here we go. So Gabor now has been updated, is much closer, is less than 100 meters, and his status is amber because now it doesn't meet the safety condition that we have set for its location. So this is a bit a way of making some assumptions on location in an automatic way. Now we are not going to ignore who has been marked as safe even if without a response. That is again just a way to filter on thousands of students and prioritize those that are in a danger status or in an unknown status. And after that, we carry on with all the other ones, assess the status for good. Once we established communication between people, human communication over a voice call typically, and then we can close the event when everybody's safe. So that is a bit about the process. Now, jumping again into the slide, the other way of assessing status is through an initial communication that we establish with students. What I can show you now is how we have done this using bot framework, and currently work in progress is through an automatic voice call initiated via Skype and using the cognitive services for understanding the response, the reply by the student and processing this information. So both framework and cognitive services are two relatively new services by Microsoft. They are delivered through the Azure cloud clearly, and there is an API, an SDK for development of applications. The bot framework is, as the name implies, is for building bots. So is a text communication where the bot initiates a conversation and the student replies on a limited set of options. In our case is yes and no. I will show you this in code in a moment. And the bot understands the response and then process the next message until the final status is assessed. So it's typical a text conversation. Cognitive services is a very broad scope. is voice synthesis and recognition, is facial, so face picture recognition, and a lot of other things. We are experimenting at the moment with voice synthesis and recognition. So Skype will initiate the conversation using some pre-recorded messages in English at the moment, and then we try to understand the response of the student using the cognitive services for voice recognition. Challenges. First of all, background noise. If people are on the street and probably there are police, ambulance, or whatever, the communication will be very noisy. So the cognitive services have a way to filter out background noise, but we're working on it. There are good margins of improvement on quality of the message. And the second challenge is actually on the language itself, because we are initiating communication in English, and our students are in schools to learn English, but their background obviously is not as a native English speaker, so they have accent. So the challenge there is to understand their accent and process the response in the most accurate way. And on top of that, the majority of the students are in a initial, in a basic level of English course, so they may not be able to understand the question, they may not be able to articulate an answer. So voice calls that are automated are a bit of a challenge at the moment. So there is, as said, a good margin of improvements that can be applied, but the technology is promising, and in any case, this is really meant for an initial assessment before actually contacting the student for real, I mean, with a human operator in the school. So, bot framework, I can show you something now around the bot framework. So let me jump into the portal first, which, if I remember, is dev bot framework. Here it is. If I log in on my dashboard, we should be able to see my bot. So dev.botframework.com is your URL of reference if you want to build a bot. It's not complicated, but there are a few things to consider. I will jump also in a quick demonstration of the source code in a second. You define where the emergency response bot sits, which is at this endpoint. There is an app ID that you want to keep a secret and use it for authentication of your app, and then you define different channels. So these channels are basically the way the bot communicates with your end users. Direct line is a HTTP request. We are using direct line for sending SMS. Actually, there is already a channel for sending SMS via Twilio, but we are not using Twilio. So Twilio is not our SMS gateway. Our SMS gateway provider has its own APIs, which is exposed as a RESTful JSON API. If you remember, in the Logic App workflow, there was a post to our endpoint here, bob.ef.com, sending a message. The message was, are you okay, to a specific student. That will call my direct line. We are working with Skype, as said, and web chat is just for testing purposes. So we're not actually initiating any web chat with a student for reaching out on a real emergency. That is purely for testing. And the next channel we want to add is Facebook Messenger. Unfortunately, WhatsApp is not programmable, we had conversation with Facebook because obviously WhatsApp is owned by Facebook. They said at the moment there is not an API or an SDK for communicating with WhatsApp programmatically, so we'll stick to Messenger for whoever is still on Facebook. Now, a bit of code in Visual Studio. Let me close a bit of things here. Here we go. So that was my data model, and this is my bot framework. So first of all, what is a bot from a developer perspective? A bot is a web API. And if you install your bot framework in Visual Studio and create a new project, so let me just show you this. If you go into Visual Studio and create a new project, if I remember correctly, that will open a template which we search for bot. Here we go. It's a bot application. It's a template to build a bot application for the Microsoft bot framework. What it does is basically creating, let me just zoom out a bit, this should be good enough to see like this. It will add a reference to the Microsoft bot connector and the bot app services. Those two namespaces contains the objects, the classes that are necessary to communicate with my backend. But if you have ever developed a web API, you will know that any controller that you define inherits from API controller, and that's exactly the same for my bot controller, my messages controller. There is an authentication though that is necessary, and you define through this attribute. This attribute defines the authentication of the bot using the app ID that was defined in the portal. And then you have purely asynchronous actions in the controller to send or receive messages. In this case, we have a post of an activity. So an activity is a message and a reply that is exchanged between the bot and the end user. So if the activity it comes from the bot, so it comes from the school, then identifies the next message, define what is the reply, and all happens asynchronously. So we have the await and async pattern here, and then return this as a response. Otherwise, if the incoming activity is come from the student, then we read the message, understand the message, again we define a reply, and we send the reply back. Now, what is a reply? A reply is basically defined again as a class where we obviously we have to reference our bot framework in here, and this class has an interesting design. Is a collection of properties. These properties obviously have a name, and the name is the ID of the message that you want to send. Again, if you remember in the Logic App workflow, the ID of the message that the workflow trigger is the #1 message that we send to the student, which was called "Are you okay?" So named after the property, that's the first message that we send. The actual message is contained into the prompt attribute. So the name of the property is the message ID. The prompt attribute is the actual text, where with some placeholders that replace with the name of the student. The property is of a type reply options. Reply options is an enumeration that contains all the acceptable terms that a student can provide. So these are the options that the message, the bot, will understand in the message. So in Are you okay? The options are yes or no. And this is defined by a term. Now, because some people may reply also okay, you can specify alternatives. So terms, if you see this, let me zoom in a bit. If you see terms, you have a list of alternatives. So yes is the default one, and you can define okay, or yup, or yay, and whatever. So then here you define all your alternatives that you want to send, that the bot is able to understand. So that's pretty much very quickly how the bot works and communicate with the students. So if we go back to our dashboard here, and let me zoom in again so it will be a bit more visible. Now we said, I don't know, Caroline, right? So Caroline, we send a message. There is some confusion on names here. Jennifer, it's Caroline. Okay, I will double check that. Okay, interesting. And Caroline, we send a message, yes or no. She didn't reply, so what happened to her? She's unknown. Now, if she replied, the bot will assess the status and put as a safe or not. So I have a bot simulator here, which is a quick app to simulate a channel to the bot. So if I pick SMS, okay, and the student was Caroline Muller here, and sorry, let me go back here. The question is, hi Caroline, typo here, I need to fix it. This is Bob from EF School. Are you okay? Reply yes or no. So in here, we go and say, yes, it is case insensitive, so I can type anything. And then I send a message. Now this is simulating sending an SMS. Let me refresh the dashboard, and everything works well. Where is Caroline? Here it is. Caroline now is safe. And that's exactly my message that has been sent exactly now. Okay, so this is the time zone of the server, which is the US time zone and US date format. Yes, so because it's yes, yes is one of the acceptable reply options by the bot, is understood to be a positive one. So the business logic defines yes as safe status, and Caroline has been marked as safe in the emergency dashboard. Alrighty, so let me see how that works. Just a summary. We have seen this in the code briefly. They're basically a controller, the bot controller, initiate the communication. It is a web API, as said. If it comes from the school, then I have a look into all the options for communication and send the first message, then send the second message, then send the third message in order. So I keep a history of all the messages that has been sent for each student. And that also is for legal reason, as said at the beginning. If instead if the message is coming from the student, obviously look up the student, by ID. The ID is coming from SharePoint and is sent to the bot API as a header to the RESTful call. Add this communication to the history and assess the status as we have seen in the brief demo, based obviously on the reply. That really brings us to the end. And what we have seen is there is an emergency event. A workflow takes care of bringing student information that are in the active school from Dynamic CRM, where all the sales data and the entities data is stored, obviously, and create a dashboard into SharePoint. This dashboard is in SharePoint mainly for accessibility, because not all the school operators are in Dynamic CRM. Dynamic CRM is for sales automation. School operators don't have access to Dynamic CRM, so we couldn't really build this in Dynamics itself. Simply, we are not licensed for it. That's it. The SharePoint instead is our intranet. So all our school operators are in the Active Directory. They have access to our SharePoint. They can access the dashboard. Once the workflow completes and sends all the message also to the Azure IoT Hub for the last detected location, and the initial message to the student via the bot framework, then the safety status is assessed, an initial filter generated, and then school operators actively call those that are marked as in danger first, unknown, and then lastly the safe ones. What's next? Everything I just said I briefly describe into an article which is on msdynamicsworld.com, so feel free to have a look. I will add the slides and the source code for what obviously I can disclose, and a follow-up email will contain information on how to download everything that you have seen today. And then I'm presenting these sessions also in conferences. CRM Saturday is at the moment a European conference. I'm on the board. I'm a board member of CRM Saturday, and so yes, I was saying about a couple of conferences. I want, for those of you guys at least that are based in Europe, maybe a bit easier to have access. CRM Saturday in London in January, and in Dublin, Ireland in March. And the CRM User Group Summit, EMEA, in Amsterdam later in April. Just some reference if you want to meet in person, have a chat, we can have a nice conversation. That's me. That's everything for now. Feel free to reach out for any other questions and doubts. Thank you for attending. I open up to questions if there are any, and I'm happy to answer them now. In the how much time do we have? We have short than 6 minutes. Okay. So one of the question is a bot just a glorified WCF service? Is a web API. So I think I addressed this already during the presentation. It's not a WCF, it's really a RESTful API. You can send an activity. An activity is an input to a post message, so a REST post, and the activity is actually a JSON message. Okay. Anything else? Will this seminar be recorded? Yes, it is recorded. Thanks, Paul, for your comment. And I keep it open for another couple of minutes or a few more. Any other questions?
Stefano, there's a question here about the difference between logic apps and flow.
Flow, yes, yes. Thanks for pointing this out. Good question, actually. I have the same. Not much different. Not much difference. It is the same framework. The target is slightly different. Flow is really meant for purely power user with no development background. Logic apps, you can have some advanced settings where you can go into the nitty-gritty details of the message and apply a bit of logic in terms of if conditions. So there are a few actions, a few capabilities in logic apps that you can't do in Flow, because again, logic apps as a target as a developer or a kind of IT advanced pro, and Flow instead sit more at power user. But they are built on the same framework, they have the same triggers, the same number of connectors. So either use either one depending on where you actually sit in terms of skill set. To be honest, most of I think I could do everything with Flow. I haven't tried, but there is nothing in my integration workflow that is so particularly sophisticated that will require the Logic Apps advanced features. I think I can do everything with Flow. I haven't tried, but I have a good bet that 99% of the things can be done with Flow.
Okay, well, I'm not seeing any other questions, Stefano, so perhaps we should start wrapping up at this point.
I think so, yes. Thanks, Jason. Again, thanks everybody for attending. Recording will be made available in the next days. You will receive a follow-up email with a few pointers to the slide and any other resources that I'm able to share. Thanks again, and speak soon.
All right, thank you, Stefano. Again, great working with you to put this together and to hear the full details of it. Thank you also to everyone in the audience for questions and your attention today. With that, we will conclude today's event. Have a great day, everybody.